Today we're going to learn about HTTP caching, and it's an introduction to these concepts, but it's also a bit of a story how my team in CTM has used the information in this talk to go from a very slow website and a pretty poor user experience to a much faster website and hopefully a much better experience for our users. So you might be thinking, why should I care about caching? And one reason is this. So this is Google's page speed score, and this is the score that my team in Compare the Market was getting before we started all this work. So this is a score that reflects your speed, but it also gives recommendations. And these words, leverage browser caching, haunted me for months. I used to have nightmares about this because it was a real priority for our team, and it was also something that our boss and my boss's boss cared about because our site was really slow. But at the end of all this journey, we got to here, and there's a lot more to site speed than just caching, but caching gave us a really massive boost. I think you can query the Google API and see how many points you're scoring for fixing certain issues, and implementing caching gave us 17 points. So it was a really big piece of work that we did. And in your own teams or even in your own side projects, if you're seeing this, then hopefully the stuff in this talk will help. So the reason that Google cares about it and they tell you to fix it is because the internet isn't instantaneous. And even though it feels like things are happening very quickly on the internet, they're not. And you're kind of basically constrained by the speed of light, and there's not much you can do about it. If you have a website in London and somebody in New York is requesting your page, that trip is going to take 100 milliseconds. And Amazon did a study about how quickly do things feel instant, and it's about 200 milliseconds. So if you go over that, people are starting to notice a delay. So with 100 milliseconds, you've already lost half of your instantaneous perceived speed. So it's something that you really want to reduce. But 100 milliseconds is difficult to imagine in human terms. So let's put that into something that's easier for us to understand. So imagine if 100 milliseconds was actually 10 years. This would be the scenario where you don't have any caching in place and you do have to go across the Atlantic to get your stuff. If you implement caching, you can take that down to a relative 6 minutes. So that's a huge difference in terms of what your users are experiencing. And these numbers come from this slide, which is called Numbers Every Programmer Should Know. And someone told me that this slide is presentation suicide because there's so much information on it. So I won't go spend too much time on this, but this is where this 6 minute figure comes from. This is if you're just reading your file from RAM. And this is if you have to go across the Atlantic. It's taking 8 years. And I can tell you from experience that you want to avoid trips to Australia because they're going to take nearly 20 years in relative time. So how do we get this massive benefit? How do we go from 10 years to 6 minutes? And the answer is we have a copy of all the stuff we need inside the computer. So when you first boot up Chrome, it will be on disk, or your browser, it will read from disk. But after that, it can read from memory. So rather than having to go to a server on the other side of the world, it can literally just read it straight from your machine. And what do we cache? So we want to cache anything that is going to be a large size across the wire, so images, JS, CSS, and to some extent HTML. I'll come back to why HTML is kind of a gray area, but anything that's not changing super frequently, and if you've got 600K of JavaScript, you don't want to have to download that every time the user loads the page. We want to save that and let them load it from memory. And there are 3 places that we should implement a good caching strategy. The browser, the CDN, which is a content delivery network, and I'll go into more detail about what that means, and also your server. And to make this clearer, the analogy that we're going to use in the presentation is you can kind of think of caching as like cooking dinner. So imagine you're cooking your favorite recipe and you need a bunch of ingredients to do it. The best possible outcome for you is that they're already in your fridge. You have everything you need inside your house. You don't even have to leave your home to get what you want. Second best is the CDN. And you can think of the CDN as like a supermarket. So it's geographically close to you, but it's still not as good as being inside your house. And the worst case is you have to go all the way to the farm to get your bespoke fresh eggs or something, and you really want to have to avoid doing that. So I'll go through each of these and look at some of the caching best practices and also some of the gotchas that we faced in our team and how we solve them. So the first one is the browser. This is your fridge. So this is a really high-level display of the decision that the browser is making, and I'll go into this in more detail. If you can't read this in the back, then I'll read it out for you. But imagine you're here, you're loading the website. It could be the BGL homepage. The first decision that your computer is going to make is, do I have this in the cache or not? If I don't have it in the cache, I have to go across the internet. It could take me a comparable 10 years to do so. But if I do, I can just load it straight from my cache. And this loop, that's the 6-minute, 120 nanosecond loop that we want to keep in. So, I mean, this is pretty high level and doesn't really tell you much, but now I'll go into how this actually happens at the HTTP level and how you can use all these techniques to make your site faster. So this is when you make that first request to the server, this is what you get back. This is the HTTP response, and this is for an image. And I've extracted out the important parts in terms of caching. So there's 2 headers the server will send you back that tell you how long you can cache something for. And you'll see later why this was very confusing for us. So there's 2 ways. One is expires. The server is saying, so this is a very old asset, but imagine this said 2019. The server is saying, this will expire on the 15th of October, 2019, and you're free to keep using it until then. The other way is the server says, this has an age that you have to keep it for in seconds. And because I've been spending way too much time doing caching lately, I know this is 24 hours, but you're basically saying from the point that you get the asset, keep it for this long. And yeah, in my team, we found this quite confusing. We were like, which one should we use? Should we have both? And in terms of the differences, so max age is relative. From the time that each user gets it, it will add this many seconds. But expires is absolute. If it says the 1st of January 2019, everybody in the world who has that asset will have it expire at the same time. And the other thing is that max age will take priority. So if max age is missing, it will use expires, but if max age is there, it will just look at that. So which is better? Does anyone want to shout out a guess about which one they think we should use? Max age. Do you have a guess why? Yeah, that's right. So there's 2 reasons. So the one that Freddie mentioned is you have more control over the date. And this is a kind of strange niche case that you could get, but you could have a situation where you DDoS yourself with expires. Because imagine if you have 1 million customers and they all visit the page once a day, and you tell them, cache this JavaScript file until the 1st of January 2019 at midday. And then midday, 1st of January, they all come back, and suddenly 1 million people have to go to your server and get this file. So you'll see this traffic pattern where you've got no traffic, everyone's got it cached, and then bam, you've got suddenly 1 million people hitting your site. So most servers are going to be able to hopefully handle this. You're not going to bring your own site down, but you are going to get strange traffic patterns if you use expires. And the other thing is that you don't know what strange clocks people have got their machine set to. You don't have to worry about time zones with MaxAge. It's just saying keep it for this many seconds. So if your users are in Australia or the UK, the time zones won't come into play. So it's a lot simpler in that sense. And just in terms of best practices around this, this is how Facebook does it. So you can see here that they don't have expires, they're only using MaxAge. This number in seconds is a year, and you might, when I've showed this to people before, something they say is, this seems really bizarre. Facebook is caching their JavaScript for a year, surely they change it more often than that. And so if you're wondering the same thing, it's a good question, and I'll come to that later in cache busting. So the next section of the talk is where it gets probably the most dense. So at this point, does anyone have any questions about what's come so far before we get into the more intense stuff? Cool. So what happens when the year passes? Imagine you've said, keep this JavaScript for a year's up. What happens now? So you could imagine a scenario where we say, hey, this is the BGL logo, keep it for a year, and then at the end of the year, people are going to go and get it, but it hasn't changed. We're not changing our logo once a year. So what you don't want then is that they re-download something that they already have, because that would just be a waste of bandwidth. So the big question the browser has to answer is, has the file changed or not? And there are two ways to do this. In the expires world, we use a last modified date. So we say, this file was changed in 2014. So if you need to get a new copy and it hasn't changed since then, you can just use what you've got. And the more modern way using cache control and MaxAge is we hash the file. So we take it byte for byte, we generate a hash that corresponds to that file, and we know then if the copy we've got is the same or different. And in terms of how this actually works, so here's a response that shows this coming back from the server. So this is the E tag. So this one isn't an MD5 hash. You can handle this in any way, but this is basically a fingerprint of the file that says this is what the file is. And here is the last modified date. So this file last changed here, and if you've got the same version, just keep using that. So getting into a bit more low-level HTTP stuff now, there's only 2 slides of this, but this is really the decisions that your browser is making. So imagine that the user's over here on their machine at home, they make a request for some document, and the server responds back and says, here it is, it was last modified on this date, and its fingerprint is this. We say to them, look, you can keep this for a week, but then a week runs out, and they need to know, do they need a new copy or not? So what the browser then does is makes a conditional request. They send this header that says, if it's been modified since this point, or if you don't have a copy that matches the fingerprint that I do, then send me a new one. But otherwise, the browser will just send back 3 or 4 not modified, which means what you've got is fine, keep using it. So when I drew up this slide and showed my girlfriend, she said it made her want to vomit. She said, it's clear that you're a back-end developer and I can tell why they don't let you near the CSS at your work. So she encouraged me to make it a bit cleaner. So I dropped the whole side about expires because that's old school way of handling this, and we'll just look at how they do it with MaxAge. So if you only remember one thing from this talk, this flowchart is it, because this is how the browser is working out whether to use the cache or not. So each time the browser loads your website, it says, has this many seconds passed? If If the number of seconds hasn't passed, so say let's keep it for a week. If a week isn't up yet, just use what's in the cache. But if a week has passed, then the browser needs to work out, do I have the latest version or not? So it will then send this conditional request and say, has this file changed? If it hasn't changed, use the cache. So down this whole side of the tree, we're trying to always use the cache and keep it in this really quick loop. But if it has changed, then I need to get a new version. And that's the only time that we'll have to download the whole new file. So some of you might be wondering, you know, this sounds like a pretty good system, but what if we do change our logo halfway through the year? Or what if we have a marketing campaign and we need to change all the CSS on the site? We've told everybody, hey, you can keep these assets for a whole year, but now we need to push out an update. So this is a problem that we had in my team as well. And we have to use something called cache busting. So cache busting is a cool sounding name for actually a really simple and boring concept. And that is that if you change a file, you have to change the name of the file. And this works because, at least in HTTP 1, the browser will first download your HTML. It will parse it and look at all the links that it has, like I need this CSS, I need these images, and then it will make requests for those files. So on the first time that you get the HTML, if this has changed, it will say, oh, I don't know what this is. I've never seen this before. I need to get a new copy. So this string here could be anything. You can use, so in my team we use a timestamp of when the file was last modified. This could be the hash of the file. It could be, I've also seen people just use v1, v2 and auto increment. Some frameworks will handle this for you. I know Webpack has a plugin that will just do this hashing for you. And so this allows you to, and this is kind of the Facebook strategy, that cache my stuff for a year, but if it changes, I'm going to change the name and push that out to you. And the caveat to all this is that cache busting relies on short-lived HTML, because if you cache your HTML for a year, then people aren't going to get a new copy and see there's new links. So one thing we're doing is having our HTML cached for a very short amount of time so that if we do change our CSS, people will get it. So yeah, you can see Facebook doing this as well. So this is facebook.com homepage, and although their JavaScript is cached for a very long time, for their HTML they've got no cache, no store, must revalidate. So they're saying, don't save this at all. Every time you hit our site, download a new copy, and then we can push out new assets to you if we need to. So that was the browser. That's definitely the most intense part of the talk. Are there any questions at this point about browser caching? Yeah.
Aren't you then telling the browser what not to be cached pricing? So if you like have like a don't do it for a year, then you're constantly like cache busting. Not like putting loads of stuff in the browser needs to cache throughout that year.
Yeah, you would be. You'd be filling up their cache. So there was a Google study that found that 25% of people are clearing their cache once a week, either through their own behavior or through some kind of cache invalidation issue that they've got to have it cleared for them. So people's caches are getting cleared, but it will also fill up and then just start shedding stuff on least recently used. So if you haven't used something for a while, it will just dump it from the bottom of the cache. Anything else? It's a great question, and I will come to it. One other question I forgot that I've had twice and I didn't cover it is in this scenario, someone asked me, I did a practice of this talk on Friday, someone asked me, what happens here if I get a new version? Sorry, if the ETAC hasn't changed, will it update the max age? And it does. So if you say, oh, it hasn't changed in a year, I can use the cache, it will then update your max age and give you a new year or a new week, whatever you specify. So it won't just keep hitting the server, wondering if it's new. So CDNs, also called reverse proxies. So you can think of the CDN like a supermarket. So it's close to your house geographically. It doesn't take you very long to walk there and back. Hopefully it's got all the stuff that you need, but it's also shared amongst other people. So everyone in your local area is using the CDN. And if you haven't seen CDNs before, this is kind of a diagram of how they work. So imagine this is our site being served from the UK. Imagine for some reason we had customers all over the world, which at least in Competitor Market we don't, they're all in the UK. But if you have people in South America, you don't want them have to go to the UK to get the site. They can go to a little proxy server, a reverse proxy in South America and get their files, and the same for Australia and the US. So it just reduces that latency that we were talking about before. And in the keynote this morning, he was talking about that latency, and that's what we're trying to cut down. So at the CDN, the decisions that the CDN makes are pretty much the same in terms of the headers and the e-tags. You do have a little bit more granularity here, and in terms of complications, one thing that you don't want is to cache personalized information. So if I'm pushing out a page that says, hi Andy, welcome back to our site, we don't want to cache that in the CDN because then everyone's going to see Andy's name. So you can set a header which says, don't cache it in public caches, only cache it on your machine. And you can also have more granular caching policies. So you can say, in the browser, cache it for a year, but on the CDN, only cache it for 10 minutes. So the last thing is server-side caching. And the farm is a pretty good analogy here, because imagine you ran a milk farm and someone comes and says, hey, I need a liter of milk. What you really don't want to do is go to the cow, milk it, say, hold on a second, I'll put it in the bottle for you, and then here you go. What you really want is you've already milked the cow in the morning, it's already in the bottle in the fridge, and when they come and request it, you can just give it straight to them. So that's what we're really trying to do. And you can, in this example, I'm going to use Nginx, but any kind of app server, you can do the same thing. So the first user that comes in and hits Nginx is going to go to the application, go to the database and come back. This is like milking the cow over here. But then we just save the output here. We save our HTML, or it could be JSON for an API. And then the next user that comes in is only going to get to here, and they can get your pre-rendered HTML sent back to them without having to go to the database and back. So again, personalization is a challenge here. If you've got people's names, you're not going to be able to do this. So in our team, we're stripping out all the personalization and just storing HTML or JSON here. And then at this level in the browser, making API requests for the tailored information. So that is pretty much the whole talk. But the key takeaways are bring stuff as close to your users as possible, hopefully in their own homes. The browser is the best. You want it to be in that 6-minute, very quick loop. And generate less HTML and JSON if you can afford it. Ideally generate it once and save it for all the requests. And the last thing is check your own speed, whether it's your side project or your team. I've tweeted, my Twitter is in the next slide, but I've tweeted a link to these sites, and go check it out. And also just open up your own network tab and look at the headers that are coming back and see how you're doing caching and whether you can make things better for your users by speeding things up. That's it.